So, hi everyone, and welcome to this video on a simple profit maximization problem. So in here we have a function that's just a function of one variable, which in this case is Q. And our goal is basically to start with, deriving the revenue function, then formulating the profit function and finding an optimal value for Q and computing a maximum value for that particular uh, thing, right? So what do we have here? Well, we have, a cost function, and notice that our cost function that is stated is some function of Q. So this particular cost function, increases clearly with a value of Q. And here, well, to be more specific, you have this component that's a function of Q being your variable cost. This is your variable cost. And this 50 thing here being the fixed cost, right? Because it isn't dependent on a level of Q. Okay. So we also have a normal direct demand function, not an inverse demand function, given as Q is equal to 200 minus 2P. Okay, so this is a direct demand function. Direct demand function. Okay, so let's start, by solving each letter. So solution, right? So let's start with A. A is basically asking, I need to derive the total revenue function as some function of Q, right? So here we need to do sort of an intermediate step to get to that. So if you notice, our demand function is a direct demand function, which means that it's a function of P. But the problem is asking for a solution that is a problem of as a function of Q. So we need to get the inverse demand function. So get the inverse demand function. Inverse demand function. So basically, Q is equal to 200 minus 2P. I can rearrange that so I can make 2P here and then I can do Q here. So I can do 2P is equal to 200 minus Q, right? Then I divide everything by 2 and that yields me P is equal to 100 minus 0.5 Q. And this becomes my inverse demand function. So this is my inverse demand function. So notice everything now is a function of Q, right? So that demand function is a function of Q, and we can readily derive the total revenue function. So you get total revenue as a function of Q. Again, if you watch the last video, it's just P times Q, right? P is given by the demand function, so that's 100 minus 0.5 Q times Q, right? And that yields us basically 100 Q minus 0.5 Q squared, right? This is our total revenue function, right? So simple, right? Nothing too fancy. So that answers A. Now, B is basically, well, I need to now compute the profit function. And the profit function must be some function of Q, right? Well, we know from basic micro theory that profit is just total revenue minus the cost, right? And we have the cost function given in the problem. So total revenue, again, is just 100Q minus 0.5Q squared minus the entire cost function. So let me copy that. That's 1 over 6Q cubed minus 7Q squared plus 100Q plus 50. Right? So if I distribute this negative sign all throughout, right, I'm going to get the profit function, which will be 100Q minus 0.5Q squared minus 16Q cubed plus 7Q squared, okay, minus 100Q, okay, minus 50, okay? And then if I simplify, well, this cancels out with that. And then I can simplify this. This is basically, this is 1/2, right? And then this and this can be simplified. So I'm going to get 6.5, okay, Q squared minus 16Q cubed minus 50, right? So that takes care of everything. So my profit function in the in a more simplified ordering is 1 over 6Q cubed plus 6.5Q squared minus 50. So this is my profit function here. Okay. So from here, Okay, we're done with letter B basically. Now we formulated the profit as some function of Q. The goal now is to find a profit maximizing Q, right? So a profit maximizing Q star, okay, we can find that by basically using the first order condition. That is, I derive the profit function with respect to Q and equate it to zero, right? So we're gonna try to do that. So we're gonna get derivative of this dq. So if we take the derivative of this, we get minus 3 over 6 q squared by product, not by product rule, but by power rule, plus, okay, 2 times 6.5, 6.5 times 2, that's 13, plus 13q, and then the 50 goes away because there's no q there. And what we're going to do is we're going to equate this to 0, basically. We're going to equate that entire thing to 0. Then, of course, we can simplify this, this is going to be minus 0.5 q squared plus 13q is equal to 0, which means that 13q is equal to 0.5 q squared. If I divide both sides by 0.5, 0.5 q, right? What we're basically gonna be left with would be q on this side, so that this cancels out and this cancels out, right? 0.5 q, right? And what we get here, this cancels out 13 divided by 0.5, okay, 13 divided by 0.5 is just gonna be 26, right? So we're going to basically get that equivalently, right? So we get Q star is equal to 26. Okay, so that's letter C. Okay, that's the profit maximizing level of output. And the last question is, what is the maximum profit? Well, all we need to do, okay, is basically plug in that Q star into the profit function. Well, the profit function, right, if you recall, is equal to negative 1 over 6 Q cubed, right, plus 6.5 Q squared, right, minus 50. So if I plug in the 26, I get minus 1 over 6 times 26 cubed, right? Plus 6.526 squared minus 50. Well, how do we get the first? Well, we need to do 26 cubed. So that's 26 times 26 times 26. That's 17,576 divided by 6. We get minus 2,929.3333 plus, okay, 26 times 26 is this, times 6.5, which is 4,394 minus 50. And if we simplify everything, well, all we're gonna do is 4,394 minus 2,929.3333. That's 1,464 minus an additional 50. And I get my final answer of 1,414.6667, right? So that in this case is the maximum profit. So quite easy. Again, starting from the total revenue function, then deriving the profit function and obtaining the first order condition, we were able to derive the maximum profit. So thank you for your attention, and I'll see you in the next video. Thank you very much.